Hello my dear students, welcome back. How was the quiz? Good, I'm glad to hear that. I'm so proud of you that you're taking the quiz and here you are back to learn more. Well, in this sub-lesson, we're going to talk about how to determine if a triangle is a right angle triangle, alright? Now, what happens if it's not a right angle triangle? What kind of angle it is? It is acute or obtuse. So let's understand this word acute and obtuse angle, alright? First, let's understand first, okay? Now, when you have a straight line, okay? When Mr. Matt to cut a vertical line which makes perpendicular to that line, that's where a right angle forms. See that makes 90 degrees, all right? So that angle is 90. If I to move this line below 90, okay, below 90, that's why it becomes acute. It's like acute. You see, anything smaller than 90, kind of something small, you call acute, am I right? So that's why you call that acute angle, all right? So once it goes below the 90, it's called acute angle, all right? Acute angle. Now, when it goes above the 90, this direction, it's called obtuse angle. Obtuse angle. See the difference between acute angle when it goes less than 90, okay? Obtuse angle is greater than 90. So this is the 90 degrees, okay, line, all right? So when it goes over. So now, let's say if the triangle, okay, let's say this is the line, okay? Now, let's say this is a right angle triangle, okay? If Mr. Mac to increase this line, okay, let's start with decrease, okay? Let's say decrease. When I decrease this line, okay, so this is considered acute, all right? Acute angle, am I right? Acute angle. Now, look at that, the distance from this point to this point. Can you see the difference? When the angle gets smaller from 90 degrees, in other words, become acute angle, the length gets shorter. The smaller the angle is, the shorter the length is going to be. See that? Alright? So now look what happens when the angle gets greater than the 90. Okay, let's Mr. Mac put a line like that. Now look at this. Now this is considered what? Obtuse. It goes greater than 90. See that? When it becomes obtuse, look at the length. It's get longer. Alright? So now this is the new length. When the angle is an obtuse angle. Okay, so when the angle is obtuse, so now the length is longer. All right, so I want you to understand. All right, so what happened? That means this is considered what? This is C. This is C. All right, that means we know that a squared plus b squared equals to c squared. Now this is when does this equation is true? When the angle is what? 90 degrees, all right? When the triangle is 90 degrees, let's say this is A, this is B, and this is C, all right? Then we know A squared plus B squared equals to C squared. And that is true, all right? Now what happens when it gets smaller, the angle gets smaller? That means become obtuse angle. Now the A is right there, B is right there, the C is right there. That means what's that? A squared plus B squared gets less, all right? So in other words, C becomes less, okay? So that means A squared plus B squared is get greater than C squared. See that? Because this is equal. So now when this gets shorter, what happens? A squared plus B squared will be greater, and that gives you the acute angle. Acute angle. Okay, it's going to be acute angle triangle. When the acute angle triangle, it's A squared plus B squared is greater than C squared. Now when is the obtuse? Now look at this. When the angle gets greater, see that? It gets more than 90 degrees. So now look at the C. It's getting bigger. Okay, so now look at that. It's getting greater. See that? C. So when it's obtuse, so now this is A and this is now this is A and this is B. Okay, so you got A squared plus B squared. It's smaller than C squared. But look at that, C squared got greater. C became greater. See that? From equal, and now it becomes greater. Alright, and that makes it this one obtuse angle. So if I had to determine, alright, if that triangle is an acute or obtuse or right angle by using this principle right here. Okay, let's do a problem. Let's see if that triangle is a right angle triangle, acute triangle or obtuse triangle. Okay, let's say Mr. Mac to give you A equals to 3, B equals to 4, C equals to 5. Alright, if this is a right angle triangle, so it would be what? A squared plus B squared should equals to C squared. Am I right? So let's use that as a mold. Alright, so let's that as a template. So we're going to take all this and substitute inside and see if that happens or not. Let's start with A. A is 3, so it'll be 3 squared, and B is 4, 4 squared, and C is 5, so 5 squared. And we know that 5 squared means 5 times 5, which is 25. We're going to see this side also become 25. 3 squared will be 9. 3 times 3 is 9. 4 squared is 4 times 4 is 16. 9 plus 16 is, so 16 plus 9, 6 plus 9 is 15, 5 carry 1, 1 plus 1 is 2, 25. So that proves this triangle, okay, with a length of, let's say, 3 centimeters, 4 centimeters, and 5 centimeters, it's a right angle triangle. Okay, so it's a right angle triangle. It's a right angle triangle. Okay, now let's say Mr. Mac to give you another one. Let's say if I were to give you, let's say 12, A is 12, and B is 5, and then I say C is 15. Alright, and we want to see if this one is a right angle triangle, acute triangle, or a obtuse angle triangle. Okay, let Mr. Mac erase the board. Okay, let's erase the board so I get some space, and I'll be back in a few seconds. My dear student, let's rewrite what I gave you earlier, which is A equals to 12, B equals to 5, and C equals to 15. We want to see if this is a right angle triangle or a obtuse angle triangle or acute angle triangle. Alright, so what do we do? Let's pretend they are right angle triangle and use the right angle triangle Pythagorean theorem formula. Okay, A squared plus B squared equals to C squared. Alright, so we know, always keep in mind that the longest one is always the C. Okay, so the longest one, so in this case you can either pick A or B, doesn't matter, but always C, the longest one, which is the hypotenuse. Okay, so we know A is 12, so we're going to put 12 squared, B is 5 squared, and C is 15 squared. The reason why I say in this case I pretty much said A, B, C. Now if I had to give you, let's say, X, Y, Z, Z, okay, kind of like this, and you should know you can either put A or B on this too, okay, but this one is automatically become the C. Alright, keep in mind. Okay, good. 12 times 12 is 144, 5 times 5 is 25. So goal is to prove that both sides comes to equal. Alright, so 15 times 15 is, and we know it's 225, or we can multiply 15 times 15, line them up, 5 times 5 is 25, and then 5 times, and then put 5, carry the 2, 5 times 1 is 5, plus 2 is 7, and then 1 times 5 is 5, and then 1 times 1 is 1, and then 5, 7 plus 5 is 12, 2 carry 1, and 1 plus 1 is 2, so 225. Now let's add this too. So 144 plus 25, so 4 plus 5 is 9, 4 plus 2 is 6, and then 1. It comes to 169, and over here it becomes 225. They're not equal. So they're not equal. But which one is greater? So 169 is smaller, so 225 is greater. That means C squared is greater. So in other words, A squared plus B squared, C squared is greater. That what that tells you. If C squared is greater, if we have a right angle triangle, that means this is equal. This is when it's right angle triangle, A squared plus B squared equals to C squared, that one. Now the C squared is greater, that means like this. What it tells you? What is this angle? See, it's going more than 90 degrees. So that makes it obtuse. Okay, obtuse angle. Okay, obtuse angle, triangle. Obtuse angle, triangle. See that? Obtuse. Okay, because see that the C is now is longer compared to this C. Okay, this C is longer. See that? That makes it, this one is C is greater. Alright? Okay, let's do another one. Let's say, for example, Mr. Mac, to give you, let's say x equals to 8, and then y equals to 15, and then z equals to 16. Alright? So now I want you to able to identify which one is A, B, and C. So we know the longest line is always is what? The C. Okay, so in this case Z is going to be your C. Okay, so we can assign either one of them A or B, doesn't matter. Okay, we can say this is A, this is B, but very important, this is your C. Between these three lines, that's the longest. Alright, the three measurement, let's say 8 centimeter, 15 centimeter, and 16 centimeter, and this will be the bigger number. Alright, so now let's line it up. So we're going to say A squared plus B squared should equals to C squared. That means this measurement makes it what? Right angle triangle. Alright, so let's do that. So 8 squared plus 15 squared equals to 16 squared. So 8 squared is 8 times 8, which is 64. 15 squared is 225. And 16 squared is 16 times 16. So let's times them. 16, line it up with another 16. 6 times 6 is 36. 6, 3. 6 times 1 is 6, plus 3 is 9. 1 times 6, we're going to start right here. 1 times 6 is 6. 1 times 1 is 1. So 6, 9 plus 6 is 5. Carry 1, 9 plus 6 is 15. 5 carry 1, 1 plus 1 is 2. So it comes to 256. Let's add this to 225, add with 64, 5 plus 4 is 9, 2 plus 6 is 8, and then 2. So this gives it 289. No, they're not equal. But who's greater? 289 is greater. So in other words, that means A squared plus B squared is greater than C squared. So if C is smaller, that means tells you what? The C, let's say it falls right here. See that? It goes less than 90. So that makes this is acute angle. That's right. So that makes this is acute angle. So this measurement right here gives you acute angle triangle. See that? Does that make sense? See that? That makes this is acute angle triangle. Okay? Because C is smaller than C squared is smaller to A squared plus B squared. And that makes it acute. When it's a greater than A squared plus B squared, it's obtuse. And when they're equal, it's a right angle triangle. Alright? Okay, good. Well, let Mr. Mac erase the board and let's learn more about it, okay? And I'll be back with you in a few seconds. Alright, my dear student, now let's say for example, okay, we take a scenario. The scenario is Mr. Mac wants to build a frame. Alright, I want to build a frame, okay, and in order for me to build a frame, I want to make sure this frame is perfect rectangle. Alright, now when I say the word rectangle, what does that mean? That means all the corners ought to be what? Right angle, am I right? Okay, but I don't have a measuring tape. Anything kind of scale to a measuring device to find the angle. But based on the length itself, I want to make sure it's a perfect rectangle. Am I right? Okay, so my measurement is I'm going to have this one to be 15 centimeters and this one to be 20 centimeters. All right. okay, 15 centimeters and 20 centimeters. And then I measured from this corner to this corner. It turned out to be 25 centimeters. Alright, now look at this. I got 15, 20 and then 25. In order for this frame to be perfect square or rectangle, I'm sorry. In order for this frame to be a perfect rectangle, and you know that this corner has to be what? Right angle. Okay, right angle. For me to prove it that this frame is perfect rectangle, how do I do it? What do I need to do? And you know that I already got the measurements. I know the length of this, I know the length of this, and then I measured it from here to there, 25 centimeters. Exactly. One way to prove that this is a perfect rectangle is using the theorem, Pythagoras theorem, okay, which is a squared plus b squared equals to c squared. In other words, this squared plus that squared should equals to that squared. If I can prove that, that makes what this is going to be what? A right angle. Because if it's a perfect right angle, this three measurement falls in together. Let's do that, okay? So let's take 15, let's say this is A, this is B, and definitely this is going to be C. The C is always the longest, the hypotenuse, alright? So we're going to say A is 15 squared, and we're going to add that with 20 squared, and we want to prove it. If this is a perfect rectangle, that means it should be equal to 25 squared. Okay, so 15 times 15, and we already done it several times. We should know by now, which is 15 times 15 is 225. 20 times 20. Now 2 times 2 is 4, and then you got 20 got 1 0, another 20 got another 0, 2 0. Just put 0 behind it, 2 0. See that? And 25 times 25. Okay, let's use the long multiplication. 25 times 25. 5 times 5 is 25. 5 carry 2. 5 times 2 is 10. Plus 2 is 12. And we're going to multiply with the 2 here. We're going to start right there. 2 times 5 is 10. 0 carry 1. 2 times 2 is 2. Plus 1 is 5. And that makes it 5, 2, 1 plus 5 is 6. So 625. So we want to see if when I add this, must give me 625 in order for this to be a perfect rectangle. Alright? Because you know that this makes it a right angle. Alright? Okay, so let's do that. So 225. I'm going to add that with 400. 5 plus 0 is 5. 2 plus 0 is 2. 2 plus 4 is 6. So that gives me 625. It does 625. That tells you what? This is a right angle. That makes it, this is a perfect rectangle. Exactly. Okay? Pretty easy, isn't it? So I can give you word problems so many different ways. But the key thing is you need to understand, in order to make sure this is a right angle, it should fulfill Pythagoras theorem. In other words, a squared plus b squared should equals to c squared. These three should fall in together like this. If not, then if it's this is off or this is off, it is not. So then you have to decide whether it's a obtuse angle or acute angle, triangle. Alright? Okay, good. Well, that should prepare you for hands-on practice. Alright? Okay, good. Well, let's check and see what Pablo's doing. I'm not going to tell you what he's doing. No, actually, he's getting ready for the hands-on practice, just like you are and Mr. Mac is, alright? So we all three of us are ready for hands-on practice. Okay, give me a few seconds. I'll be back and we can do some hands-on practice, okay? Alright, I'll be there in a few seconds. Alright, my dear students, are you ready for some hands-on practice? Alright, well, let's call Pablo out, okay? Alright, Pablo, come on over, Pablo. Bring the worksheet with you. Yes, Pablo, with our hands-on practice worksheet. He's going to hand over the worksheet. Be sure to pause the video, alright? Okay, and then invite Mr. Mackey, and then we can work together, alright? Okay, have fun. Whoa, alright. Not bad, you just give a few problems. Did you talk him into that? Alright, okay, good. I know it's a short lesson, okay, good. Alright, let's do it, okay? But before that, how did you do? Good job. I'm proud of you. I'm so proud of you. Well done. Okay, so let's do it together, okay? So you can compare the notes. So the problem 1 says identify the type of angle M, okay, for each of the 3 ABC. Either acute, obtuse, or right angle. Okay, let's do that. Okay, the first one. Now, 1A, you are given a triangle, and then we want to figure out if this is a M, if this is a acute, obtuse, or right angle. How do we do that? First, let's put down all the measurements. 5 centimeters, and then you're given 12 centimeters, and then 14 centimeters. Now, we're going to assume always that as though they all are right angle, okay, because we're going to use the Pythagoras theorem, okay. And what is the Pythagoras theorem? That means a squared plus b squared is equal to c squared. Exactly. That means it's going to be right angle triangle if this fulfills the a squared plus b squared equals to c squared. So this is going to be your c, and this is going to be your A, B. Doesn't matter. The A, B, it can be interchangeable. The biggest thing is C. C is always the longest, which is the opposite to the angle of reference that we want to see, whether it's a right angle or obtuse or acute. Okay, so now let's substitute. So we know A is 12, so we're going to put 12 squared, and B is 5, we're going to put 5 squared, and C is 14 squared. 12 times 12 is 144, because our timetable range 5 times 5 is 25. Now let's do the 14 squared, which is 14 times 14. So let's line it up. So 14, line it up with another 14. So 4 times 4 is 16. So we're going to put 6, carry 1. 4 times 1 is 4, plus 1 is 5. We're going to times with 1. So we'll start right there. 1 times 4 is 4. 1 times 1 is 1. Alright, 6. And then 5 plus 4 is 9. And then we're going to bring 1 down. So it gives 196. Now we're going to add this 2. If that gives you 196, that makes it what type of a triangle this is going to be? Right angle triangle. If it's not, we're going to decide whether it's an obtuse angle or acute angle. Okay, so let's add 144 with 25. So 144 plus 25. 4 plus 5 is 9. 4 plus 2 is 6. And then bring 1 down. So it gives you 169, and this is 196. Are they same? No, they're not same. Okay, that means 169 is smaller than 196. That means what does it tell you? A squared plus b squared smaller, or in other words, c squared is greater. That means this line is greater than the 90 for the what it ought to be, not to be, this one to be a right angle. Okay, in other words, so if this to be right angle, it will be short like that. So this would have been a right angle. That angle would have been, in order to make this one to be a right angle, the length could have been shorter. So now, since this already past the 90, M is a obtuse. Exactly, M is a obtuse angle. M is a obtuse angle. Alright, good. And you got it? Good job. Okay, now let's do B. Now B, you're given another triangle. Okay, and then you're given a measurement 8 centimeters, 15 centimeters, and then 17 centimeters. And this is the M right here. Okay, and we want to find out if this M is this angle is a right angle or acute angle or obtuse angle. Alright, so let's pretend it's a right angle. So we're going to use the Pythagoras theorem, alright, which is the a squared plus b squared equals to c squared. And we know, let's find out which one is A, B, C. So biggest thing is C, okay? So this is the C. Then we can put this one A and B, okay? So we know A is 8 centimeters, it means 8 squared, and B is 15 centimeters. We're just going to take the 15 and square it, and then C is going to be 17 centimeter, which we won't take only the 17 and then square it. Alright, 8 times 8 is, which is 8 squared is 8 times 8, which is 64, and then 15 times 15, 15 squared is 15 times 15, and we know that's 225, and then 17 times 17 is, so let's use the long multiplication, line it up, 17 with 17, 7 times 7 is 49, 9, 4, and then 7 times 1 is 7, plus 4 is 11, alright? Then we're going to times it with 1. We're going to start right here. 1 times 7 is 7, 1 times 1 is 1. So 9, 1 plus 7 is 8, 1 plus 1 is 2. So that gives us 289. So now we want to add this 2 and see if it comes to 289. Okay, so let's line it up. So 225, I'm going to line it up with 64. I'm going to add that. 5 plus 4 is 9, 2 plus 6 is 8, and then bring the 2. So that's 289 on this side. That means equals to 289 on that side. Are they equal? Yes, it is. So what that tells you? M is a right angle triangle, because when it's a right angle triangle, only time that it is right angle triangle is when this measurements all fulfills Pythagoras theorem, and it does. See that? This side comes to 289, that side also comes to 289. That makes this one is a right angle triangle. M is a right angle. Okay, so M is a right angle. Okay, M is a right angle. Alright, in other words, it's a right angled triangle. Alright, okay, good. Okay, let's do C. Well, let Mr. Mac erase the board and then we'll do C, and I'll be back with you in a few seconds. Alright, my dear student, let's do C now. Okay, the C also given a triangle. Okay, we want to determine whether that triangle is a right angle triangle, acute angle, or obtuse. Alright, so this is the reference angle that we're looking for, M, and you're given 15 centimeters, 20 centimeters, and 23 centimeters. Okay, so we're going to pretend as though this is a right angle triangle. That means we're going to use that Pythagoras theorem, which is a squared plus b squared equals to c squared. Alright, so let's substitute. Now first let's identify which one is C. See that the longest of the three would be this one right there, that would be C. So we're just going to say that's A and this is B. So A is 20 squared, and then B is 15 squared, and C is 23 squared. Okay, so we're going to see if they equals out. Okay, 20 squared means 20 times 20, which is 400, and 15 squared is 15 times 15, 225, and 23 squared is 23 times 23. So let's times that up. Use the long multiplication approach. Let's line it up. 3 times 3 is 9, 3 times 2 is 6, and then when times with 2, I'm going to start right there. 2 times 3 is 6, 2 times 2 is 4, and then 9, 6 plus 6 is 12, 2 carry 1, 1 plus 4 is 5. So that gives me 529. Now we want to add this 2 and see what that gives it. Okay, so let's line it up. So line it up, 400 with 225. 0 plus 5 is 5, 0 plus 2 is 2, 4 plus 2 is 6, and that gives me 625, and it's not equal to 529, so they're not equal. Alright, that means 625 is greater than 529. That means we translate that into right there. That means a squared plus b squared is greater than c squared. That means the c is shorter. Okay, that means the c is shorter. If let's say in order to make it 90 degrees, alright, would have been, let's say something like this, that makes it 90 degrees. So that means C went shorter than that. That means if this is a 90 degrees, so this is a acute, obtuse, or right angle. It's acute because it's a squared plus b squared is greater than c squared. So that means this is smaller, the c squared is smaller than a squared plus b squared, and that falls under what category? The angle would be under acute. Alright, because we know that if it's a 90 degrees, Okay, let's say this is what 90 degrees would have been. So now the new length, which is the 23, fall right there. That means it fell less than the 90 degrees. When it fall less than 90 degrees, makes this, what kind of angle is that? Acute angle. So acute angle. So that makes M is a acute angle. M is a acute angle. Alright, you got that? Good job. Okay, good. Let's do problem 2. Problem 2 is a triangle XYZ is a right angle triangle. Prove that triangle XWZ is also a right angled triangle. Okay, so we're given a triangle. So let's see this right there. And then another triangle. Okay, so we got two triangles. So being told this triangle is for sure it's right angle. Okay, right angle triangle, which is the X, Y, Z. Okay, and then this has been given 24 centimeters and this one 7 centimeters. Now they want us to prove it that XWZ is also a right angle triangle, and given this is 20 centimeters and this one is 15 centimeters. So how to prove that triangle, which is this one, XWZ, is a right angle triangle? How to prove it? But we already been told this one is a right angle triangle. Very good. How do we prove it? That means we first use this information to find the length of that. Once we know the length, then we use the Pythagoras theorem, a squared plus b squared equals to c squared. If these three fulfill that a squared plus b squared equals to c squared, that tells us that XWZ is a right angle triangle. Alright, okay, good. So let's first find this length. Okay, so that means a squared plus b squared equals to c squared. So let's say, we know this is the c we're looking for, and we're going to put this is a and this is b. Alright, so a is a 24 squared plus, now this is problem number 2. Okay, problem number 2. So 24 squared plus 7 squared equals to c squared. Alright, so we can substitute a with 24, b with 7. So 24 squared, 24 times 24, we're going to use the long multiplication method. So we're going to line it up, 24 times 24. 4 times 4 is 16, 6 carry 1, 4 times 2 is 8, plus 1 is 9. I'm going to times with 2, I'm going to start right there. 2 times 4 is 8, 2 times 2 is 4. Bring the 6 straight down, 9 plus 8 is 17, 7 carry 1, 1 plus 4 is 5. So that gives me 576. Okay, so that gives me 576. Okay, so 576 plus 7 times 7, 7 squared is 7 times 7, which is 49 equals to c squared. So let's combine that, let's add that. Okay, so we're going to put 576, we're going to add that with 49, line them up. 6 plus 9 is 15, 5 carry 1, 1 plus 7 is 8, 8 plus 4 is 12. So 2 carry 1, 1 plus 5 is 6. So that gives us 625, and that's c squared. And we're looking for c. So now to find c, which is this one, c squared, I'm going to take a square root of that. If I square root this side, also square root on the other side. So c equals 2, and we know from our previous 625 square root, you know that 25 times 25 is 625. Okay, so we know that 25 times 25 is 625. You only need one of that, which is c equals to 25. So that means we know this is 25 centimeters. Alright, in order for this triangle to be a right angle triangle, this squared plus this squared should equals to 25 squared. Alright, which means this one right here. Okay, let's substitute. Okay, so let's say this is, when we know this is c, let's say we take this is a and this is b. So we can take 20 squared plus 15 squared should equal to 25 squared. Alright, so you know 20 squared means 20 times 20. What's 20 times 20? 400. And what about 15 times 15? 225. And what about 25 times 25? 625. Okay, so we know that's 625. So let's combine this two. If this one turns out to be 625, that means this triangle is a right angle triangle. Okay, so let's do that. 400. So 400, we're going to add that with 225. 0 plus 5 is 5, 0 plus 2 is 2, 4 plus 2 is 6. Look at that. It does give us 625. Okay, so that tells us, so this is also 625 equals to 625 on the other side. This side equals to the other side. So that tells us this triangle is also a right angle triangle. See that? How the problems can be manipulated in so many different ways. It's just that the thing is, you got to understand the basic foundation, which means what? The Pythagoras theorem says a squared plus b squared equals to c squared only when the triangle is a right angle triangle. With that in idea, you should able to any type of problem. I can take pieces here, pieces there, and put that together and question you. But knowing, understanding the basic of Pythagoras theorem, that's what's matter. Okay? Alright, my dear students, Pablo just walked by and let us know that's time for quiz. That's right, it's time for quiz. Okay, my dear students, well, have fun with the quiz, and this is also the end of the lesson on Pythagoras theorem. It's very powerful. Be sure to understand this before you take the quiz. Okay, if you think that you need to, go back and review what Mr. Mac taught you. Do it. Go back and do it. Okay, go back and review before you take the quiz. All right, that's the beauty about online video learning. Okay, so you always have the opportunity to go back and watch the video over and over again as many times as you want. Okay, all right, be sure to do that. Okay, make sure every time when you take a quiz, make sure you understand, really understand before you take the quiz. All right, so don't rush, just take your time, enjoy it, have fun with it, because mathematics is fun and mathematics is easy, and scoring mathematics is a year to bring that to you, and also to unleash the power of mathematics in you. Alright? Alright, my dear student. I will see you soon. Okay? I'll see you in the next lesson. Bye-bye.